Hi all. So in this particular video, we'll try to find out the shape functions of an element called as a quadratic element. Okay. So now this is the same element that we have taken into consideration. You will be able to find that it falls under the category of natural coordinate system because you look into all the axes. It is -1 and 0, 0 and 0, and 1 and 0. So basically, we have ensured that this plus or minus 1 has not been crossed. So this falls under the category of the natural coordinate system. So this also will tell you that this is where we have fixed the origin point, or node 2 is actually the origin point. Okay, so sorry, without wasting any time further, we'll look on to the Lagrange's method. So we are trying to find out the shape function of the first node. So this is the first node that we are going to consider. So if you are going to consider the first node, this will not be considered. Only node number 2 and node number 3 will be taken into consideration. So again, speaking, so the value of x has no part in it because it is just a one-dimensional element we are considering. Okay, so every time only the x comes into picture, y will not be coming into picture at all. So here the value is 0 and over here the value of x is -1. Okay, so as it goes by the Lagrange's method, x minus x2, which is present over here, and x minus x3. Okay, now if you have noted, x1 term has not appeared in this term at all, where the shape function of node 1 is considered. In the denominator, wherever x was appearing, just substitute the x1 term over there. Okay, so if you just substitute the values, it is x minus 0 over here. Sorry. So if you just substitute the values, you will be able to find x minus 0, x minus 1. The value of x, you can find it as -1 over here. Substitute it. Then the shape function of the first node is x into x minus 1 divided by 2. Okay. So similar to this, we'll also try to find out the shape function of the second node. Okay. So once we are looking into the second node, here again, as we stated further, x only will be considered, the y term will not be considered. Okay, sorry, this will not be there, right? So n2 is what we are going to consider. So which means we are not going to have the term x2. So it is x minus x1 into x minus x3, and in the denominator just replace the term x with x2 because it is for the second node. So x2 minus x1 into x2 minus x3. Now if you substitute the values, x minus x1 is 1, but minus of -1, so x plus 1 into x minus x3 is 1. And the value of x for the second node obviously is 0 for us. So it is 0 plus 1, 0 minus 1. Okay, so without no further delay, you will look into the equation directly. So x plus 1 into x minus 1 divided by -1. So you just do a small math. Here again it is a plus b into a minus b. So it is a square minus b square, or basically 1 minus x square. Okay, now we have found out the shape function of the second node. Repeat it for the third node. So again for the third node, what we are trying to do is, this will not be considered on the numerator. So it is x minus 0, which is present over here, and then into x minus of -1, which is x plus 1. So that will be present in the numerator. So you can find it over here, x minus x1. So it is x minus of -1, x plus 1, x minus x2, x2 is 0, so x minus 0. Okay, and then in the denominator, replace this x with x3, and the value of x3, you can find it over here, is just 1. Substitute it, you are going to find out the shape function of the node 3. Sorry, now if you look into the previous problems, previous derivation of quadratic equation, which is by using the local coordinate system. Okay, so what we have done in the local coordinate system is pretty big. So this is the element that we have considered, and if you look into it, we have used the Pascal triangle, we have got to the characteristic equation, and using the three boundary conditions we have found out what is the value of constants, basically sorry, a, b and c respectively, and again then the values of a, b, c has been substituted back in the characteristic equation over here, and then all these phi 1 terms, phi 2 terms, phi 3 terms are clubbed together. That has given us the shape functions, whereas this, when the same element, but if you consider, or if we consider natural coordinate system, it's very simple. There is no need of a Pascal's triangle. Directly we have found out the shape functions of node 1, shape functions of node 2 and shape functions of node 3. Okay, so depending upon the usage we have or depending upon the usage we can get to a conclusion which coordinate is much better when we are looking into the element type. Okay, so with this we'll stop and we'll conclude the videos of the quadratic element. Thank you. நான் தான் வரேன்னு சொன்னேன்ல.